Okay, in today's video, we're going to start with adding fractions. Now, at this point, I'm going to start using, bigger numbers as such than the previous videos because I assume that if you're learning to add fractions and such, that you'd probably like to see a more variety of numbers. Plus, I think that I've used 2 and 4 and 1 too many times, so yeah, we're just gonna go at it now. So basically a fraction is written as basically a division of two numbers, right? A fraction, this goes back to our dividing video, which, 4, let's say 4 divided by 4. I keep on doing the percent sign. Boy, probably if I someday show statistics, I'll probably start writing division signs. But anyway, 4 divided by 4, which is equal to 4/4. And this is how we basically represent fractions, this form. And usually you show it like this. That's basically a fraction. And basically what this says, like we said before, how many groups of 4 are in 4? Well, we know that this is 1. And this creates an identity for us, right? A number that's divided by itself will give the identity of 1. And that's a very important concept in mathematics, because if you have two equivalent values, you know that when you divide them, they will have to be 1. So, let's say you were adding fractions, right? Let's say you were adding 1/4 plus 1/4. And this is going to be my favorite video of the series because I always love drawing pies. So let's say we have a pie, right? And we were to divide it into 4s. So what are we trying to do here? We have a 1/4 of the pie here, and we have another 1/4 of the pie here. Well, we know that's half of a pie, right? But how are we going to add these? So this is important. When you add fractions, you have to make sure that they have the same denominator. You cannot add fractions properly as long as they do not. You cannot do it without a proper equal denominator. So this right here, and I'll write it. This right here is what we call the numerator. And here, this is what we call the denominator. Now, when you're adding fractions, like I said before, and I'm going to keep on saying this forever, they have to have the same denominator. So this is the first thing you look at, and we see that they both have the same denominator. So basically, what we can do is, if they have the same denominators, then we can just add their numerators, right? We could just add their numerators. So this is equivalent to 2/4. But now you're asking me, but you just colored in a half of pie, so how could we have 2/4 of a pie? Well, let me talk to you about reduction now. So this fraction can be reduced, and typically, when you write numbers, you might be, well, when you write numbers, you typically want to have them in the lowest fractional form when you give an answer, because it's usually easier that way. So we know that this can be reduced, right? Because each one of these numbers, they share a divisor in common. And what would that divisor be? You want a divisor that will not give you a remainder. So let's see, you know that these share both 2 in common, right? So if you write it out, the percent sign again, gosh. If you write it out, 2 divided by 2, you know that that's equal 1, because how many groups of 2 are there in 1? You know that how many groups of 2 are there in 2? You know that there are 1. And the same thing, you have 4 divided by 2. And how many groups of 2 are there in 4? Well, that's 2. So what did you do here? Well, basically what you did here was you found a number that both of the numerator and denominator is divided by, so that you could get it into a more basic version. So you know that this is equal to 1/2. So my drawing is obviously not flawed now, because you know that I circled in 1/2 of the pi, and after we added our number, well, you know that that's equivalent. So now I'm going to throw you a curveball. So let's have, you know, one second. So let's have 1/2 plus 1/4. So now there's something different here from the last thing. And what do we find are different? And what did I tell you? I told you that we cannot add numbers unless they have the same denominator, right? Well, let's say, you know, you were to add these, okay? Let's say, I don't know, for some reason you would think that, well, let's make a drawing first. Let's make a pi, because I really like pi. So we know that we're adding 1/2 of the pi with another 1/4 of the pi. So what do we have here? We have 3/4 of a pi. So boy, we better get 3/4 of a pi somehow. So how will we get this from here? Well, you basically look at this number right here, the denominator, and you think about, you typically look at the lower number, and in this situation it's 2, and you ask yourself, what can I multiply that denominator with, this denominator here, so that it will be the same denominator here? Well, basically you can multiply this 1/2 by 2. Well, actually, one second. You can multiply this by 2, and you will basically have the you multiply the denominator by 2. So, and then that means you have to multiply the numerator by 2. And why isn't this a bad thing to do, you might ask? You might be like, oh, this is a very, why are you doing this? Well, what's 2 over 2? 2 over 2 is 1, so we're not really changing the integrity of this fraction. We're just making it into a higher version of itself, right? Beforehand, we showed that 2/4 in a previous video, or maybe this one, I don't remember. This is equal to 2/4, right? But we remember that this goes back down to 1/2. So it's not really a big deal. So we just determined that we can write this as 2/4 plus 1/4, because we just made an equivalence for this, because we know that 1/2 equals 2/4. So we have same denominators now, and that's the only parameter we need for adding fractions. So all you have to do now is add the numerator and maintain the denominator. And what did we just get? We just got 3/4. And look at that, we colored in 3/4 of the pi. So it's not it's not flawed. Now I'm going to use new numbers now. So let's say I have 1/25, okay? And I add to it a negative 1/25. Well, let's look at the first situation we had here. We had 25 and 25, they're the same denominator, so we can just add, right? But we look at the numerators here, and the same idea of adding happens. You're starting on 1 on the number line, and you're going backwards 1. So this is equal to 0 over 25. And we know that when the numerator of a fraction is 0, then the entire thing has to be 0. And why does this make sense? Because you took, basically, this is the equivalent as if I said something like 1 plus negative 1 equals 0. Because I added the positive version with the negative version, then I will have to get the identity of 0. So now let's look at the situation where we add two negatives. So let's say I have negative 1 over 1,000. And I add negative, actually, let's do negative 4 over 1,000. So we have same denominator, so we know that we're fine there. And now the same idea happens when you add two negatives together. You just say that it's like adding the two positives together, but you just put a negative sign with it. So 4 plus 1 is 5, but we have two negative signs here, so we know that this is negative 5. But there's still another step here, right? You have this fraction, but it's not in its lowest form, and typically when we write fractions, we want them in its lowest form. So we look at some number that these two numbers share. So typically what you want to do is you want to like take the numerator and just divide it by both. You take the numerator number and divide it, and use that number to divide the numerator and the denominator. So we know negative 5 divided by 5 is equal to, well, let's look at it this way. How many groups of 5 will it take to get to negative 5? Well, if we go backwards 5 on the number line, it will take 5 steps to get to negative 5. But, so we know that because it will take one group of 5 steps, but which direction on the number line did we go? We went backwards. So we know that this has to be negative 1. Now, in the situation that you have 1,000 divided by 5, what is this equal to? Well, this says how many groups of 5 is equal to 1,000. And this is saying that that there are 200 groups of 5 in 1,000. And you can check this, because let's say if I was to write something like 200 times 5, well, I should get 1,000. And oh well, look what I got there. So this fraction will reduce, and we just showed what it will reduce into. We just show that this right here, this is equivalent to negative 1 over 200. Okay, so basically that's the video for adding. The next one will be about fractions, and yeah, thanks for watching, and comment what you thought about the video.